Hello and welcome back. In this video we'll cover section 1.3, which is on trigonometric functions. So to begin with, we should look at right triangles. And a right triangle is going to be any triangle where one angle is a right angle. To give this some terminology, the side opposite of the right angle is normally called the hypotenuse. Oops. With the Pythagorean Theorem, we can give a relationship between the sides of a right triangle. So if we call the sides, or the side lengths adjacent to the right angle A and B, and then the side opposite is the length of the hypotenuse C, we have A squared plus B squared is equal to C squared. This is probably something that you've seen before, and we can use this to create a formula for the distance between 2 points. So if I have 2 points in the plane, let's call them P and R, and P I will call x1, y1, and R will be the point x2, y2. We can draw this line between them, and we can ask, well, what is the distance, which I'll call d, between these 2 points. And again, right away, there's not really a nice easy way to see what this length will be, except I can draw a right triangle. So I'll draw straight down from this point and straight over from this point, and this will form a right angle. We can find the length of d by solving for the length of the hypotenuse using the Pythagorean Theorem. So if I want to know what c is, I just have to take the square root of this side. So c is going to be a squared plus b squared, and then we take the square root of all that. So what I need to do is I need to find the length of both these sides, square them, add them together, and take the square root. So the length of this bottom side down here, so the distance from this point to this point is going to be how far over we go in x, which is going to be the same thing as x2 minus x1. So I'll square that. This is going to be x2 minus x1. And then if I want to know the height, again, I just have to look at the difference in the height between these 2 points, which is going to be y2 minus y1. So y2 minus y1, and that's the difference in height, and I'll square that. We add them together and take the square root, just like up here. So the distance between 2 points can be given by this formula, where the 2 points are x1, x2, and y1, y2. And luckily, if we have just 1 point, it's pretty easy to use the distance formula when we're looking at the distance between a point and the origin, which I'll call script O. So the origin is just going to be 0, 0. So if I want to find the distance here between this point P and this and the origin, I'll call this distance R for reasons that will become apparent in later sections. Then I can use this distance formula, and the distance will be x minus 0 squared plus y minus 0 squared, and we can take the square root. But furthermore, x minus 0 squared, well, that's just x squared. Y minus 0 squared, that's just y squared. We add them together and we take the square root. So this is going to be this distance r. So we have a formula for the distance from any point x, y, and the origin. And we'll use this quite a bit. So one of the reasons that we're talking about this is we'll then use this with respect to this angle here, which I'll call theta. So we have this distance, or we have this angle theta that's popping up, and the trigonometric functions of theta will depend on x, y, and r. So let's look at these functions. So there are 6 functions that we'll look at. We have sine, cosine, tangent, cosecant, secant, and cotangent. And again, when we have an angle and we put it in standard position, this means that the initial angle is along the x-axis, and the initial side is along the x-axis, and the terminal side is going to be sort of elsewhere. In this case, we're going to consider the terminal side to be the line between the origin and the point xy. This angle, we're going to use that to calculate the values of some functions. So we can take the sine of an angle, the cosine of an angle, and so on and so forth. And it's going to depend on xy and the distance, the length of this line here, the distance from the origin, we call it script O, up to xy. So the sine is in fact going to be y over r. Cosine will be x over r, and tangent will be y over x. You may have learned in previous classes the acronym SOHCAHTOA. I want to move away from this because there are situations where SOHCAHTOA doesn't necessarily make sense. So for instance here, it's a little bit harder to see the triangle where we're looking at the opposite and adjacent and the hypotenuse. So I want to move away from that here. So the sine is always going to be the y value divided by r. Cosine is going to be the x value divided by r, and tangent is y divided by x. Cosecant, secant, and cotangent are going to be the same fractions, but they're reciprocals. So cosecant is going to be r over y, secant will be r over x, and cotangent will be x over y. So let's do a couple of examples where we calculate some of these trig functions for a given angle. So let's find the values of the 6 trig functions for the angle theta in standard position, whose terminal side ends at 3, 4. Okay, so this is a lot of words. So we're just going to find the values for the 6 trig functions. So I've got that written here. So we'll find sine, cosine, tangent, cosecant, secant, and cotangent of theta. But we need to know what theta is. So I suggest we draw a little picture. We'll have our plane, and we want this in standard position. So the first edge, the initial edge, is going to be coming straight across, and the terminal side is going to end at 3, 4. So if we come 1, 2, 3 over, and 1, 2, 3, 4, maybe that's not really to scale, but oh well. And this is the point 3, 4. We can draw a line going right up to it. And the angle that we're looking at is going to start at the x-axis and come up to this line. So this is our angle theta. So we want to know, what is the sine of this angle, the cosine of this angle. And to calculate these things, we need to know x, y, and r. Well, x and y are pretty easy. X is just going to be this x value, which is 3. Y is going to be the y value, which is 4. And r is going to be the length of this line here. So again, the length of that is going to be the square root of x squared plus y squared. So the square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. And simplifying this, we've got the square root of 25, which happens to be 5. So we have x, y, and r. So now we can just plug these into our functions. So the sine is always going to be y over r. So y up here is going to be 4, r is going to be 5. The cosine of theta is going to be x over r. So it's going to be 3 over 5. And then the tangent will be y over x. So it's going to be 4 over 3. Cool. So we have all this, the cosecant, secant, and cotangent. The reason I have these in this order is because this makes finding these values really simple. They're just the reciprocals. So we just flip over each of these fractions and we get the other one. So given an angle in standard position, we can calculate the trig functions for that. So let's do another one. So let's find the values of the six trig functions I have written here. The angle theta in, again, standard position, whose terminal side ends at -12, -5. So here we'll draw our x and y axes. We're going to be at -12, -5. So it means 12 backwards and only 5 down. So maybe something like right there. So a lot further to the left than we are down. And again, we have our line here. So since this is in standard position, we're starting from the x-axis and going all the way over. So this is the angle that we're looking at. Again, our point is -12, -5. And we also need to know r, this distance. So x is going to be -12, y is going to be -5, and r will be our square root of x squared plus y squared. -12 squared is 144. -5 squared is going to be 25. Notice that when we square the negatives will cancel. So then we get the square root of 144 and 25, that's 169, which happens to be 13. So we have 12, -5, and 13. So far so good. And then we can plug in these values. So the sign is going to be y over r. So we have -5 over 13. And you'll notice that this is a negative fraction, which is absolutely fine. The six trig functions can take positive values, negative values, or even 0, as we'll see in a little bit. This is going to be a negative fraction, -5 over 13. Cosine is going to be x over r, so this is going to be -12 over 13. Again, this is negative. And then the tangent is going to be y over x. And what you'll notice is that -5 divided by -12, the negative signs cancel, and we'll just get 5 over 12. So we do have to pay a little bit of attention to when these trig functions are going to be positive or negative. And again, it only comes from the x, y, and r. So if we know what x, y, and r, what these values are, it is very easy to just plug them into these formulas. Cosecant, secant, and cotangent, again, we just take the reciprocal of these fractions. So this is going to be -13 fifths. This is going to be -13 twelfths. And here we'll have 5 twelfths becomes 12 fifths. So finding these trig functions should be fairly straightforward, provided that we know exactly what these guys are. And I think I will stop there and continue in the next video.